Hello, everyone, and welcome to Lancaster Safety's Focus 4 webinar. My name is Emily, and today I am joined by Dean Bortz, one of our safety professionals.
Thank you, Emily. I'm glad to be here today.
So for too many years, we've seen workplace accidents happen for a number of reasons. After much evaluation, OSHA came up with the Focus 4, and the Focus 4 refers to the 4 most common fatal incident types in the construction industry. Today's webinar will review these most concerning hazards and the primary causes of these incidents. Before we get started, here is a little bit about us at Lancaster Safety. We are a full-service OSHA compliance firm that has a primary focus on making sure that each employee gets home safely from work every day. Our slogan is taking safety beyond the standard, and this means that we want to go above OSHA standards to make sure that our clients are building a safety culture and being safe because they want to, not because they have to. We want to provide top-notch service that truly makes an impact on people's lives. So Dean, for those joining us today, can you tell us a little bit about your safety background?
Emily, it's my pleasure. Again, thank you for allowing me to join you, and it's been a pleasure to work with Lancaster Safety for the past handful of years. I was exposed to safety as a young person. I was on a project doing day labor. I was in middle school, and I saw a person get run over by a backhoe. It's not like the movies, if any of you have ever seen something like that. The sight and the sound was bad enough, and the shock, of course, will always be with me. But what it did, it made me angry. It made me upset because there was no reason. After I started doing more and more work, I realized that neither party knew the other was there. There was no high visibility. There was no backup alarm on the piece of equipment. In other words, like most accidents, 100% avoidable. So I decided that whatever I did and continue to do, that safety and doing things safely would be a part of what I do. So I look forward to joining you as we discuss the Focus 4.
Great, thank you so much, Dean. We really do appreciate you being here today. So the Focus 4 that we're talking about today is something that we could literally train on for hours. Now, this is an introduction webinar intended for us to provide you with an overview of the topic.
Exactly. So what is the Focus 4? Basically, it refers to 4 types of incidents that occur in the construction industry. We're going to review these types of incidents and provide examples, as well as discuss the importance of hazard recognition for each one of these incident types. Also provide information regarding costs of fall accidents, hazards identifications, requirements, examples, procedures, and the nature of hazards in the work area.
So as we just mentioned, there are 4 incident types in the construction industry that cause a majority of fatalities. And these are the incidents that are most commonly referred to as the Focus 4. So the 4 fatal types of incidents in the construction industry are falls, electrocution, struck by, and caught in between incidents. Now, these 4 incident types are the most common fatal incident types every year. So let's talk about each of these incident types in more detail. That way we can better understand how they can actually be prevented. So let's start by talking about the incident type that is the most common, and that is falls.
Emily, absolutely. Over 1/3 of fatal accidents and incidents in the construction industry are caused by a fall. This has been identified as the most fatal incident type, so we have to go into further detail to understand how this happens. As a matter of fact, falls at work and at home are the second cause of accidental death in the United States, only behind automobile crashes.
So it might seem obvious why we want to learn about and understand the top 4 most fatal incidents, but we truly cannot stress this enough.
Exactly. As we now know, falls are the #1 cause of injury and fatality in the construction industry. Over 100,000 injuries and 200 or more fatalities are caused every year by falls. This number is absolutely unacceptable. And as an employer, you do have a responsibility to understand and protect employees from the hazards and unsafe workplace conditions. So there's a number of fall prevention and protection methods that are often overlooked or bypassed.
So before we get started about talking about falls in more detail, let's take a quick quiz. So where do you think that most falls occur in the construction industry? A, scaffolds, B, ladders, C, platforms, D, roofs, or E, A and D. Go ahead and take a minute to look this over and type in your answer to the chat box.
Alrighty, time's up. So where do most falls occur? The answer is E, falls from scaffolds and roofs.
So falls commonly happen from unprotected sides and holes, walking working surfaces that are not constructed properly, improper use of equipment to access heights, failure to properly use a personal fall arrest system, and lastly, slips and trips that are caused by poor housekeeping.
Exactly, Emily. And while a majority of falls happen from heights of 11 feet or higher, many injuries and fatalities can also occur from falls on the same level or just a few feet off the ground.
Not only are falls the most common type of fatal incident in the construction industry, but it's also the most costly type of incident as well.
Emily, you're correct. In fact, between the years of 2011 and 2013, fall accidents cost companies over $1 million. And you can't put a price on an employee's life, but these costs could have been avoided entirely with the right methods of prevention and protection. I refer you to 29 CFR 1926. That is the OSHA safety and health requirements for construction. Subpart M will give you a lot of detail on dimensions and placements. So we're not going to go into a lot of detail in this presentation today. Please refer to Subpart M for additional information.
Before we talk about the types of fall protection that can be used in this industry, let's take another quiz real quick. So at what height is fall protection required in construction work environments? A, 5 feet, B, 6 feet, C, 7 feet, or D, 8 feet? Go ahead and take a minute to again read over the answers and put your answer into the chat box.
All right, very good. The correct answer is B, 6 feet. Fall protection is required when employees are working from a height of 6 feet or more above a lower level, or on a walking surfaces where they could fall 6 feet or more into an excavation or opening. It's important that all work surfaces be inspected prior to work to ensure that the surface is strong enough to support the work being performed. Now we've taken a look at that, let's take a deeper look at fall protection.
So when do you as an employee need to be protected from a fall hazard? As we just reviewed, OSHA requires that fall prevention or fall protection is to be provided for employees working in construction environments at heights of 6 feet or greater.
That is absolutely correct. So let's take a look at some specific areas where fall protection is required by OSHA standards. Working in a hoist area, where I'm moving materials to an upper level or taking debris down to a lower level. Working in elevated areas such as ramps, runways, or walkways. Areas where there are holes, and holes should be covered to protect employees from tripping or stepping into holes. Covers should be marked, secured, and withstand 2 times any imposed load on them. Also, working near wall openings, windows, doors, etc., or when dangerous equipment is present below the work surface, as well as working in or near excavations.
So there are many different ways that we can protect employees from suffering a fall-related injury or fatality. So let's talk about some of these options. First off, we're going to talk about safety nets. Safety nets are an option for fall protection for whenever you're working in high-rise buildings. So safety nets have to extend at least 8 feet outside of the working surface, but that can also depend on the height of the working surface to begin with. Now, once constructed, these safety nets do have to be inspected to ensure their integrity and make sure that they would be safe to use if a fall were to occur.
Yes, Emily, safety nets are an excellent option in a variety of areas, not just high rises. Next up, we have guardrail systems. Most people are familiar with guardrails. They're commonly used to prevent an employee from being exposed to a fall hazard and suffering from a fall. So in order to provide sufficient protection, guardrails meet these requirements. First, the top rail height typically is 42 inches, plus or minus 3 inches, above the walking working surface. Second, a mid-rail is installed about halfway between the top rail and the working level, usually around 21 inches. Toe boards, if installed, help prevent objects or materials from falling into areas below. They're at least 3.5 inches high, not more than a quarter inch above the walking working surface. Also, we don't want to have any openings in the guardrail system that are more than 19 inches wide. The system also must be capable of withstanding at least 200 pounds of force on the top rail when applied within 2 inches in any outward or downward direction. There are additional requirements and options with guardrail systems. For openings on ramps and runways, there must be guardrails erected on each unprotected side. Guardrails can be constructed of a variety of materials. There are many options for you. So if you choose guardrails as a fall protection system, again, ensure it meets the measurement requirements, but you can select a variety of materials to accomplish these requirements.
All right, moving right along, we're now going to talk about warning lines. So warning lines are commonly used on roof areas to identify the areas in which work can occur safely without fall protection and where work cannot occur if fall protection is not used. So warning lines are used to warn employees of an unprotected edge. Essentially, a warning line system is a means to provide a visual warning of where work can and cannot be performed. So to be compliant with warning line system requirements, the following must be met. The lines used for warning lines are to be made of ropes, wires, or chains. The lines must be placed at no less than 6 feet away from the edge, meaning if working more than 6 feet from the edge and within the warning line area, additional fall protection is not required. But if working past the warning line system and within 6 feet of the roof's edge, additional fall protection must be worn. The warning lines must also be set up to withstand tripping force of 16 pounds, and the lines must be constructed in a means to have the line be no lower than 34 inches, but also no higher than 39 inches. It's important to note that for roof work or any other work occurring where warning lines are used, work cannot occur until after the warning line system is properly set up and providing that visual. So if the warning line area is not yet set up, work cannot occur near the unprotected edge, even if you are more than 6 feet back. You do need to have things set up and be in place properly before you can work without fall protection.
Right. So warning lines, another option can be something called a controlled or limited access zone. What a controlled access zone is an area meant for only qualified personnel to enter and work in. When properly designated, again, by ropes, wire, or chain, controlled access zones allow for work to take place without the use of additional protection, such as guardrails, safety nets, or personal fall arrest systems. These controlled access zones can be set up no less than 6 feet, but no more than 25 feet away from an unprotected edge. Once the area is set up with ropes, wires, or chains, they must be flagged with highly visible material at least every 6 feet. Controlled access zones are often used for roofing work, leading edge work where floors are being constructed, masonry, and other types of work.
Let's review safety monitoring systems. So a safety monitoring system includes an employee that is designated to prevent workers from falling from the leading edge. It's commonly used in the roofing industry, where the safety monitor is responsible for watching employees in the working area to ensure that a fall does not occur. And the sole responsibility is the monitoring of employees. So the safety monitor must be able to communicate verbally with the employees in the work area, and they must be able to always see the employee that they're monitoring where the work is occurring. Should there be an increased chance of a fall hazard or the monitor sees the employee not working safely, the safety monitor does have the competency and the authority to stop the work and keep the employees safe. And any employees in the area must follow any directions given by the safety monitor. The safety monitor can't have any other responsibilities that could take their attention away from the ones that they are monitoring.
One thing to note about the safety monitoring system, there are restrictions. For example, OSHA asks that this be used in no greater than a 412 pitch type or flat roof. There are additional dimensional requirements for using a safety monitor. Another option that is very popular is the personal fall arrest systems. Most of you probably are familiar. Guardrails and personal fall arrest systems seem to be the most common types of fall protection we see on projects. Personal fall arrest systems, again, are very common. They include a personal harness that's connected to a lanyard with snap hook and D-rings that's then attached to an anchorage point capable of withstanding and sustaining 5,000 pounds of force. A personal fall arrest system must limit a person's free fall to no more than 6 feet. For example, if a fall does occur, the personal fall arrest system limits the maximum arrest force to 1,800 pounds per square inch. So here we have an example in the pictures of the proper way to put on a personal fall arrest harness. So please note, prior to using a personal fall arrest system, all components should be inspected by the trained user of the equipment. Any defect found, it must be repaired or replaced or taken out of service. I also recommend when you're doing this to use the buddy system to make sure that people check each other, to make sure the harness is indeed donned correctly, snug enough to do its job, but not so tight that you can't do the work.
Absolutely, Dean. So we are going to look a little bit closer at these components of a fall arrest system. And we commonly refer to this as the ABCs of fall arrest systems. So the A stands for anchorage, and the anchorage is commonly referred to as the point where you are tying off. So the anchorage is the connection point used to connect you to the point of anchor. Now, B stands for body wear. So this is the personal fall arrest harness that goes around your body. And C stands for connecting device. And this is the critical link that will join the body harness that you're wearing to the anchorage point. And this would be something such as a self-retracting or shock-absorbing lanyard.
Exactly, Emily, and there's a variety of options for personal fall arrest systems. Again, you can take a look and find the one that works best for your kind of work. One common question is, what's with this 5,000 pounds at the anchorage point? I don't know any 5,000 pound people or 1,000 pound people. Well, it goes back what I call applied physics. Force equals mass times acceleration. For example, I'm 6 foot tall. If I fall and don't hit anything on the way down, end up on the ground, it takes about 2 seconds. By the time I hit the ground, I'm traveling 13 miles an hour. Now, that doesn't sound too bad, but we all have those 5-mile-an-hour bumpers on our cars and trucks. We know how well they work. When you fall 6 feet, you're going 40 plus miles an hour or more. That's why that anchorage point needs to have at least 5,000 pounds and needs to be certified by the competent person to be able to withstand that 5,000 pounds of force. So before an employee uses a personal fall arrest system, it is critical to inspect to ensure that's in suitable conditions. So here's some things to look for when you're inspecting the equipment. First, take a look at any tears or signs of wear in the harness and lanyard. Take a look for any deformed D-rings, snap hooks. Look for dirt, grease, or other substances that could affect the function of the equipment. And look at the labeling to make sure it's legible, that is indeed ready to go. If any part of the fall arrest system does not pass inspection, it should be reported to a supervisor immediately and removed from service.
So we've learned a lot about fall hazards and when fall protection is required. So let's take a look at this picture. Can you identify any areas where you see any violations related to falls?
Oh boy. Well, there are quite a few in this particular photograph. I'm sure very quickly you saw that no one, especially at the upper level, was wearing fall protection of any kind. If you take a look closely, the person holding on to the piece of sheathing in the red shirt is working more than 6 feet high and protected by anything. In fact, neither of the two employees on the roof have any type of protection. And unfortunately, they may be used to this type of work and moving around on surfaces like this. These instances are putting each employee at high risk for a fall to occur, let alone dropping material maybe striking someone below.
So let's take a look at this picture next. So what do you think is wrong with this picture in terms of the employee's fall protection? Yes, he is wearing a personal fall arrest system, but there's something quite not right about this picture.
Well, I think most of you have identified the fact that we appreciate this person doing this work. The employee is not properly connected to an anchorage point. The lanyard is attached to another material. Not only is this an insufficient anchorage point, but would also create a free fall distance greater than 6 feet.
So fall protection is of course meant to protect employees when they're exposed to a fall hazard. However, if it's used incorrectly, fall protection can be even more dangerous than not using anything at all. Just because you are wearing fall protection does not mean that it's going to properly protect the employee. So poorly constructed or damaged fall protection can provide a false sense of security and making a fall much more dangerous if it were to occur. All right, this is the last picture we're going to look at in this category. So, Dean, what do you think's going on here?
Well, boy, well, actually, there's quite a bit going on. If you take a look, you'll see that fall protection is on backwards. The lanyard's in front of the employee rather than connected with the D-ring and snap hook between the shoulder blades and the back. That's where it should be. The harness is on backwards, is not properly fitted, and is not going to provide this employee protection.
So we just spent a good bit of time discussing falls today, and we really do thank you for your participation in all of our quizzes. But we are now going to move on to the next Focus 4 item, and that is struck by incidents. Now, these account for over 10% of fatalities in the construction industry.
That's right, Emily. Struck by injuries are just as it sounds. They're caused by a worker being struck by something. For example, the number one cause of highway worker fatalities is being killed by construction equipment or in temporary traffic zones by traffic that's maintained. Vehicles entering work areas are usually the result of driver error or an improperly erected temporary traffic work zone. By the way, those of you that do this work, your best guide is something called the MUTCD, Part 6. That's the Manual of Uniform Traffic Control and Design, and it has wonderful information as well as examples of the proper way to set up temporary traffic zones. Most workers on foot are either killed or being run over by equipment, especially backing equipment, or some are killed by equipment tip over or failure. For equipment operators, the most common cause of operator fatality is equipment rollover. Many passengers of equipment are killed because they weren't in a proper seat or were riding on steps, fenders, tailgates, buckets, etc., and fell off.
So another type of instance that would be considered a struck by injury is something such as being struck by a falling object or falling piece of equipment. So up to 20% of crane fatality incidents are caused by being struck from crane tipovers or other crane failures.
Emily, you're correct. Crane or equipment incidences that help us move material can cause serious injury and death. So it's crucial that any kind of slings or rigging be inspected prior to use and be rigged by a qualified rigger. For example, they will make sure that any nylon, chain, or wire rope slings have legible tags showing capacity. And the riggers must understand the capacities of whatever sling material being used. Every sling should have a label on it showing this. And riggers need to know how to inspect slings and properly rig loads. With different types of struck by fatalities, it's important to recognize instances where they can occur. Once identified, you can eliminate these hazards using the hierarchy of controls we'll talk about next on how to work safely. Another key is just simply make sure that people in the correct position so that no one is below a load that's being raised, picked, or placed, so that as the crane moves, no one's struck by the rear or the boom of the crane.
So when considering equipment struck by incidents, many tip-over incidents occur during the loading and unloading of equipment. Now, equipment can also slide off trailers or loading ramps. So equipment operators must be cautious when they're operating to ensure that they are always aware of their surroundings.
Yes, Emily, for those working on foot, high visibility clothing allows the operator to easily identify you. In fact, the requirements are you must be identified as a person from 1,000 feet away. I also think just because you have on high visibility clothing doesn't always mean the operator can see you. I recommend even the operator wear high visibility. It's another visual signal to make sure we keep the equipment doing its job and the walking and working personnel safe. Always ensure you're not an equipment operator's blind spot or the shadow of an operator. In fact, a good rule of thumb, remain your distance from the equipment and allow the operator to communicate with you when it's safe to approach or cross its path. Don't try to slide by or get behind. That's when bad things happen.
Now, if a piece of equipment presents a rollover hazard, the operator is then in harm's way, so they must be wearing a seatbelt during operation. If employees are performing work or maintenance on equipment, they should never be working under or between equipment parts that are supported by their own hydraulics. All equipment must be properly blocked and secured.
Yes, Emily, when it comes to preventing struck by injuries, it really comes down to a few key aspects. The pre-planning, placement of equipment, operations, materials, personnel. We want to take a look and make sure that the folks doing the work are authorized, trained, that an inspection is run, pre-operation check of equipment, an overview, and oversight. If an incident ever occurs, obviously the incident must be investigated to identify the root cause in order to evaluate for future planning, training, and oversight. The purpose is not to find fault, it's to find fact so that we can make sure that that never happens again. Unfortunately, hindsight is always 20/20.
So the next focus for incident type that we will review is electrocution. So this is just crazy to me, but did you know that approximately 350 electrical related fatalities occur every year? That number just to me seems outrageous. But before we get started here, let's see what the audience knows about electrical hazards. So for electrical equipment, which of the following options represents the misuse of equipment? And there could be more than one right answer. So options include using multi-receptacle boxes designed to be mounted by fitting them with a power cord and place them on the floor, fabricating extension cords with Romex wire, using factory assembled cord sets, using equipment outdoors that is labeled for use only indoors and in dry locations, using cords or tools with worn insulation or exposed wires, and then using cords, connection devices, and fittings that are equipped with strain relief. Like I said, there could be more than one right answer here.
Emily, you're exactly right. There's quite a few here. And the start items, using multiple receptacle boxes that are designed to be mounted, but fitting them with a power cord and using them as a job-ready extension cord, or fabricating extension cords with Romex or any other kind of wire. Using equipment in an improper location. If it's rated for outdoors, use it outdoors. Indoors, indoors. Using cords or tools with worn insulation or exposed wires. Absolutely, and there's more. We know that poorly constructed or used electrical equipment can cause severe injury and even death through electrocution. So it is really crucial to understand the severity of electrical hazards in order to know how to prevent them. And this is not just for electricians and electrical workers, but it also affects people in the area.
Absolutely, Dean. In the construction industry, anyone around the working area needs to be extremely cautious. There are various instances that could yield in electrocution, such as contact with overhead power lines or contact with live circuits. Those are the most common types of electrocution incidents, but other things such as damaged cords, damaged tools, or even outdoor areas where you're working and there's a lightning strike, these can all cause severe harm to an employee.
And Emily, you're exactly right. Most people don't realize overhead power lines are not insulated. They may have a protective covering on them. I don't have to touch them. I just got to get close with tragic consequences.
So knowing how dangerous electricity is, how do we prevent electrical hazards that could lead to severe injury or even worse? Well, one thing we can do is use a ground fault circuit interrupter, which prevents the electric shock or electrocution if there were to be a faulty cord or tool. Now, it's best to use a GFCI whenever possible because it does monitor the current flow between the hot and neutral wires.
Emily, you're correct. It senses a change in the amperage of 5 milliamps. That's 5 thousandths of an amp, plus or minus the actual power that that tool or cord is using. So for indoor electrical panels, obviously we don't want to have any loose wiring or exposed wiring. We need to make sure that wiring is protected by closed boxes. If we're working with a live panel, we have to make sure it's covered and have a hard cover to prevent any sort of exposure or contact. Cardboard is not a solution here. If an electrical incident were to occur, we've got to be careful of surrounding areas. We know that electricity's home is the ground, and it will find its way there if it's through us or equipment. So it's important we maintain proper distance. If you do have an incident, obviously call for additional assistance or ask questions. Electricity is a wonderful tool for us to use and be very difficult to perform in the construction industry without it. But again, like any other tool, we want to make sure we respect it and use it properly. So for outdoor electrical exposures, you always want to maintain a distance from overhead power lines. And it's not just personnel, it's equipment, ladders, scaffolds, cranes, forklifts, trucks, a minimum distance of 10-foot clearance from a 50,000 volt exposure. And for every 1,000 volts over 50,000 volts, you add additional distance. Whenever possible, best practice, add distance when working near overhead power lines. You also must know the distance of potential arc flash. Have trained, qualified personnel perform work on live power. Do not work on energized electrical equipment unless you have no choice and you are authorized and qualified. Very important. As previously discussed, preparing to prevent an accident, it's important to take time, plan, train, inspect, oversee the process. If you are more deliberate up front, you'll get the job done correctly the first time and likely more efficiently, especially when severe hazards are present. I recall an incident with a concrete finisher using a bull float, which is sort of like a metal Swiffer, and it's a device used to make a nice finish on concrete when concrete's being after it's poured. And the handle can be adjusted by taking 5-foot sections and making the handle longer or shorter, depending on what you're finishing. I didn't see it, but I saw the aftermath. Unfortunately, he had a very long handle, was not aware of the power line overhead, pulled back to make another stroke. The metal handle contacted the power line, and he was killed instantly. So again, electricity is a wonderful, wonderful tool. But like any tool, we need to make sure we use it properly.
We are down to our last focus 4 incident category that we are going to talk about today, and that is the caught in between incident. These incidents occur when one or more employee is crushed or caught between an object in the ground or an object and another object. So things such as congested work sites, heavy equipment operation, and multiple trades working in one area, that can all contribute to a caught in between hazard.
You are correct, Emily. One of the most dangerous things we do is excavation. And again, whenever we move dirt, the earth wants to heal itself. So caught in between can happen in other ways. Trench collapse, cave-ins, rotating moving equipment, unguarded equipment parts, rollovers, equipment maintenance activities. You will not win that. In fact, we know that a cubic yard of dirt, right, which is typically how this is measured, how it's stacked, stored, etc., weighs as much as a pickup truck. So if you're caught in between that, you are not going to win.
That's a great point, Dean. We do want to think about trenches and excavations specifically in terms of at what depth is protection required in order to prevent a cave-in. So let's take a look at this question and the answers here. So do we think it's A, 3 feet, B, 5 feet, C, 7 feet, or D, 9 feet? Take a minute to think about that and you can put your answer in the chat box.
Emily, the correct answer is, according to OSHA standards, 5 feet. If an excavation is 5 feet or greater in depth, it must be protected from cave-ins.
Absolutely. Excavation cave-ins are extremely dangerous. It only takes a small amount of soil to cause serious injury. So just 2 cubic feet of soil can really restrict a buried victim, and it can affect their ability to breathe.
Exactly right, Emily. Employees may be familiar with working in trenches or excavations. The conditions and hazards are constantly changing. Weather, it can be equipment, personnel. So the key is all work needs to be performed by a competent person that not only understands the soil type they're working in, but is able to prevent dangers from a cave-in. Again, as we learned from the last quiz, any excavation 5 feet or greater must be protected. And you have several options here. You can use benching and sloping. You can use shoring, shielding, or a trench box. Now, for excavations less than 5 feet, if they pose a cave-in potential, they should also be protected to ensure employee safety. You'll see the term competent person throughout OSHA standards. To learn more about excavations, you can take a look at subpart P in the construction standard. We'll give you, again, more information. Just as in fall protection, you want a competent person that understands all options. As we see here in excavation, a competent person needs to be able to do things that will protect the employees. So the competent person, again, will make sure the excavation is inspected on a daily basis at a minimum before each shift. Make sure it's safe for folks to work in. If something changes, all of a sudden rainstorm shows up, some heavy equipment goes by, again, another inspection may be warranted. For entering and exiting the excavation, if it is 4 feet or deeper in depth, it must have proper access, such as a ladder, ramp, or walkway. In addition, there can be hazardous atmospheres and other conditions that will cause you to test and make sure that it's safe to work in here. Let's focus on the caught in between. If a cave-in were to occur, most local first responders are not fully trained or equipped to perform rescue operations. So employees working in or near excavations must be aware of these dangers and be trained on the rescue plan, the equipment being used to protect them. And we need to be very careful because, again, the operation of doing this work can cause collapse. For additional cave-ins, oftentimes are worse than the initial cave-in and can trap victim and would-be rescuers. It creates more soil pressure, and obviously it can injure a victim more severely than the initial cave-in. So it's not uncommon for an excavation cave-in caught in between to become more dangerous and more complex as the event continues to occur.
So we'll now shift gears a little bit and we'll look at crane operations that can cause caught in between hazards. When crane booms are being dismantled and the pins are removed, the boom of the crane is not fully supported. So this can cause the boom to fall and cause a caught in between incident. Now, there must always be a plan in place for the safe dismantling of cranes for this reason.
Emily, you're correct. And there's other parts of the crane too. Rotating cab, counterweights can strike victims or trap them in between other obstacles. You know what that means? The crane's radius and the crane's operation need to be properly barricaded, and no other employee should be permitted in the crane operation area. Subpart CC of the OSHA construction standard gives a detailed look at the qualifications of crane operators, signalers, riggers, and disassembly personnel. It's key that you follow those minimum requirements and more to make sure you do not have struck by hazards when dealing with cranes and derricks.
During crane operations, you want to maintain a minimum of 2 feet distance from any fixed objects. And if maintenance needs to be performed on the equipment, it must be done properly with lockout, tagout to avoid any moving parts. We can't stress enough how there are so many aspects that go into crane operations that need to be looked at, reviewed, and trained on prior to anything happening on site.
Emily, you're correct. There was a major revision that was finalized in 2018. And basically, again, I refer the audience to subpart CC, Cranes and Derricks in Construction, for additional details and information. Something else that needs to be considered when you're working your equipment, especially dump trucks, is that these trucks can become unstable when the box is raised. For if there were to be a tip over during dumping operations, it would certainly create a caught in between hazard. So again, personnel need to maintain distance from a truck that's in active operation, as well as the material unloaded. And the drivers should always remain inside the cab.
Thanks, Dean. Now, we've gotten through a lot of content today, but in summary, we really want to make sure that you understand the top 4 most fatal incidents in the construction industry, and that is what OSHA refers to as the focus 4. So falls are coming in first at over 36%, with struck by, electrocution, and caught in between incidents not too far behind.
Yes, Emily, it's unfortunate. Today, 15 will be killed at work, 2/3 of those in construction. Today, 3,000 people will be injured, 3,000 today at work, 2/3 in construction. So the incidents and examples reviewed today scratch the surface of prevention. There are key aspects to keeping your workers safe. Among them, planning, training, inspecting, maintenance oversight. And if an incident does occur, it must be fully investigated to identify the root cause and learn valuable lessons. This investigation helps you reevaluate work practices and prevent future incidences. And if you think safety is expensive, try an accident, not just financially.
We thank you so much for your time today, and we really enjoyed your participation. Now, if you are currently a client of Lancaster Safety and you need any more information, please reach out to your primary contacts. Now, if you're not a current client, we are still here to help you. So please reach out. You can find us at our website, www.lancastersafety.com, or give us a call at 888-403-6026. Thanks so much, everybody. Have a great day.
Thank you, Emily. Take care.